So our equation 1, we can simply say that is what? H is equals to what? U square sine square theta over 2g. Now, what is maximum height? Maximum height is the highest distance attained from the horizontal plane, from the point A here to the what? The highest point on the horizontal plane. So maximum height is basically the highest distance attained from this point A to the what? To the highest point on the horizontal plane. Now, moving on from the equation of motion that says what? V is equals to U plus AC. Now, let C equals to the time taken to reach the maximum height. To reach the maximum height. Now, if T is the time taken to reach the maximum height, we can simply deduce from here, also following this, that Vy is equals to what? Uy plus Ay, then T. Now, from here, we can also deduce that our final velocity in this case is what? Is 0. So we can say that 0 is equals to what? Our Uy in this case is what? U sine theta. We have U sine theta plus our A subscript y in this case is what? Minus g. Then we have our t to be our time taken. So from here we can also deduce that 0 is equals to U sine theta minus gt. U sine theta minus gt. Now we can also move on and say that what? Our U sine theta is equals to what? Gt. Now, to get the time taken, to get the formula for the time taken, we can simply say that what? We want to divide both side by what? By g. Divide both side by what? By g. Now, we can simply say that the time taken at which the time taken to reach the maximum height t is now equals to what? U sine theta over g, which is our equation 2. Now, when this object attain up to this height, we said that is what? The time taken to reach the maximum height. Now, when this object landed to the horizontal projection plane here, what do we call that? We call that the total time taken to, or let's simply say, we can simply call that what? The total time of flight. The total time of flight, which is denoted as what? As t. So now let's get the total time of flight t, which we are saying that what? It is the total time taken from this point A to the highest distance at which it reached the maximum height, then to this point B, which is the horizontal, the full horizontal distance on this projection plane. Now, simply, when this object landed to the ground, we can deduce that our h is what? Is 0. There is no maximum height. Now, from here, from equation of motion that says what? That says S is equals to ut plus 1 over 2 at squared. We can also deduce here, I said our S, which is our distance in this case. For projectile motion, it is now what? H is equals to U, which is on our vertical axis. Then our T here now, we are replacing it with what? The total time of flight, which is what? The capital letter T, plus what? 1 over 2. Then our A here, which is what? Our minus G. Minus G, then our T squared. Now, simply we can deduce that what? Our H is what? 0. Our H is 0. Then we have what? U subscript Y of T plus what? 1 over 2. Okay, from here, we can use this minus to multiply. We have minus 1 over 2 gt squared. 1 over 2 gt squared. So from here, we can simply divide. We can divide all through by what? By t. We can divide all through by t. Now, simply, when we divide all through by t, we are simply saying that what? This will be what? 0 is equal to what? T will cancel t, we have what? U subscript y. Then minus what? T will cancel t here. We are left with 1t. We are left with what? gt over 2. gt over 2. Now, from this place, we know our uy is simply what? U sine theta. Our uy is what? U sine theta. So we can simply say 0 is equals to u sine theta minus gt over 2. Alright, so we can simply deduce out u sine theta is equals to gt over 2. Alright, so we can multiply both sides by what? We can cross multiply to have what? 2u sine theta to be equals to what? gt. Now, simply because we want to get what? The total time of flight, which is our what? Our t. Now we can divide both sides by what? By g. By g. So from here, we can deduce out our formula for the total time of flight t is now equals to what? 2u sine theta over g. 2u sine theta over g, which that will be our what? Equation 3 for the projectile motion. Now, we've talked about projectile motion on the vertical projection plane. Now, let's move to the what? The horizontal projection plane. Alright, moving on to our horizontal projection or simply horizontal motion. We are simply talking about this distance from here to here. Now, we already deduced that the distance from this point A to point B is called what? It's called the range. It's called the range. So, we can also simply deduce out the ux, which is our initial velocity across the horizontal plane. Ux is what? Is u cos theta. U cos theta. Now, we have the acceleration across the horizontal plane, ax, to be what? To be 0. Acceleration across the horizontal plane is what? Is 0. Now, our formula for range is simply what? Ux times t. Ux times t, where our a is equals to 0. Also, from here, we can deduce that our formula is what? U cos theta multiplied by what? 2u sine theta over g. 2u sine theta over g, which is our formula for what? Total time of flight we deduced from our what? Our vertical motion or vertical projection. Now, from here we can deduce that what? Our r can be equal to what? u square 2 sine theta cos theta over g. Also, from trigonometry, we can simply say that what? 2 sine theta cos theta is equals to what? Sine 2 theta. Sine 2 theta. Now, from here, we can deduce that our r is equals to what? U square sine 2 theta over g. U square sine 2 theta over g. Since our what? Our 2 sine theta cos theta is simply what? Sine 2 theta, which will be our formula for range on the what? On the horizontal axis. Now let's move to solving practical examples on projectile motion. Let's move to solving practical examples on projectile motion.